Hello and welcome. I'm Konrad. I am currently DevOps engineer and I spent quite some time of my life working with servers. My server story goes back 16 years when I actually started my home lab on old Pentium 3 hardware, providing Wi-Fi to my house and two quite popular open arena servers running on my very slow, even at the time, ADSL internet. And by popular I mean a player count, as they were almost always full. So let me show you what I built now as my home lab to experiment with and also provide new production experience to myself and others. You can find here the last year's wonder, Minisforum MS-01, QNAP TBS 4648G serving as my NAS, and TP-Link Omada switches. All that hardware is powered by EATON UPS. So let's talk about this infrastructure in more detail. My fiber internet connection is coming through Leo Labs Leox ONT LXT-010H-D that connects to my TP-Link switch. Leox is quite nice customizable ONT device built by Polish company Leo Labs. It allows to configure ONT in quite details, including fiber connection details like exposing custom serial number to provider. On top of the rack, we can find Omada switches. I chose Omada because it was cheaper than Ubiquiti at the time, but now I'm quite regretting this choice, as Ubiquiti has much more great hardware, which I would like to use. But back to the topic. As you can see, I have two switches. One 8-port switch with PoE+, along with two SFP cages for 10G, and also I have 24-port switch with 4 10SFP cages. So I have quite of expandability available to me at this moment. First switch has just a very few devices connected. It's 2.5G Omada EAP 660 HD access point, Omada controller, and previously mentioned Leox ONT. The last one unfortunately is not PoE powered, but I just prefer to put it into top switch as there's plenty of room and other stuff in it. Second switch is to maintain other connections like my home lab cluster, NAS, my office room, and also my homemade router. And between those switches I've got 24-port Keystone Jack patch panel with nicely labeled ports, so I know which devices are connected where, and I can patch them to different ports on the switch if needed. There's also labels for 3 rooms in my apartment, the kitchen, the office room, and the bedroom, so I can patch cables to those rooms. AP is actually connected to Kitcher's RJ45 in the wall. So let's talk about my storage device, aka my NAS. So the next in the rack is simple rack shelf that contains QNAP TBS 4648G, and it's connected via both 2.5 gig RJ45 ports to Omada switch in bonding configuration, so I can utilize in total 5 gigabits per second from NAS. And because it's standard x86 PC, I actually installed barebone Debian onto it and used ZFS in RAID Z1 mode to provide redundancy to 4 NVMe SSDs I put inside. And each SSD is 4TB TLC, so in total I have about 12 terabytes usable storage. Now you're probably thinking, I'm crazy because no one in their right mind would create NAS from scratch, as you can just get something like true NAS. Well, believe me, I tried. It's just not possible because internal storage of that QNAP is just 3.5 gigabytes. Yes, you heard that right. And I had to do a lot of magic to even install barebone Debian. And then, after actually creating ZFS pool on NVMEs, I had to put multiple system mounts onto that RAID to be able to even update the system, because there was no space to even download updates, let alone install them. The CPU is not the greatest. It's Intel N5105, and due to very slow cryptographic algorithms, I had very weird problems with SSH performance when copying files. So what I did is I modify SSH algorithms on SSHD configuration, and I had to do a few rounds to compare performance of multiple algorithms to find out the one that still allowed me to utilize at least one full 2.5 gigabit link, so 250 megabytes per second copy should be possible. That was my goal. Without those changes, speed was hanging at around 80 megabytes per second, so it was quite bad. It's not the best solution as it lowers SSH security, but it's good enough for me at the moment. Maybe in the future I will have better CPU and I won't need to do hacks like that. The reason for all that weird configuration with ZFS is that with ZFS you can create very interesting theme provisioning. You can create multiple volumes that all share the same disk space, and this is very efficient, and something like that is not possible with other file systems also being so user-friendly at the same time. Another reason for using ZFS here is to compress everything. And unfortunately we are back at CPU topic, yes, because it is not powerful enough to do that. But after some experimentation, I found out that setting compression to ZSTD2 for my data volume is good compromise. With this setting, ZFS uses CPU quite heavy, about 70% on each core, but system and NAS is still usable. Fortunately, the decompression, which happens a lot more often, doesn't need to struggle with CPU that much, and it's almost seamless in terms of CPU usage, so it works pretty great for read-heavy use cases. Let's finally talk about the main star of the show, my Minisforum MS-01 cluster. I always wanted something that can be equipped with multiple gigabytes of memory, so I bought 3 of them mid-2024 in barebone version with lowest tier i5 CPU and equipped each of them with 96 gigs of DDR5 memory and 512 gigs of NVMe SSD. Since I had to start somewhere and I really needed the RAM much more than storage at the moment, I decided to hold on with spending money on disks. Previously, I ran regular virtual machines on this cluster using libvirt. And now you may think probably, why not Proxmox? And yes, I admit, it's quite nice. I used it in my previous job, I use it in my current job, and I'm pretty sure I will be using it in any future jobs when we'll be doing on-premise. But I just like experimenting with stuff, so I just decided to do it on my own from the very basics. And it worked. On those virtual machines I had my Kubernetes cluster set up and training Kubernetes cluster. Training, you say? Yeah, so I am also providing trainings about Kubernetes, Docker, GitLab and StarTech, so I had also secondary Kubernetes cluster that I spin up only for a few days for training sessions. But very recently I made a choice to learn something more, something new, so I moved that Kubernetes from VMs to bare metal, to those exact MS-01's devices from VMs running on them. So now I have 3 Kubernetes nodes, which are both control plane nodes and worker nodes. And now, as you can probably see, there is an issue. What happens with my trainings? Because I don't have virtual machines anymore. So hear me out. There's a solution to that, and there's a project called libvirt. It allows to run virtual machines through Kubernetes CRDs. I've tested it already and it looks very promising. Leave a comment if you want to see more real-life scenarios and problems with libvirt. My Kubernetes cluster runs multiple applications. The plan for the cluster is to be as highly available as possible, although that's not possible every time due to multiple issues like my available time or software that doesn't work properly in HA configuration. But I'm trying, okay? I'm trying. So let's finally talk about what I really have in my Kubernetes. As you can see, there are multiple namespaces. First is democratic CSI. Let's start with base Kubernetes services like storage. For this basic cluster, I didn't want to go with full-fledged Ceph. Firstly, because I have my NAS, and secondly, I didn't know Ceph that much. Of course, Ceph has its own benefits, like, well, being replicated to multiple nodes, so it's highly available, but I accepted that risk. Democratic CSI is a nice application that connects to remote system via SSH and execute commands on it to prepare volume on it, so it can configure ZFS shares and export them via NVMe over Fabric or create NFS shares. And depending on the use case, I also configured democratic CSI with a local path configuration. So how it really works is that if anything that can be shared and replicated by application itself and has only one single pod, so essentially it's a single point of failure, will be stored on my NAS. So if application needs to be moved from one server to another, it just connects to NAS and gets the data and storage from the NAS. That's exported via NFS or NVMe over Fabric. Or if your application is replicated, like GitLab Gitali or Garage, that's stored locally on the nodes. So if one of the nodes has to be shut down, the other two nodes has the data locally and application still works, given application architecture. Also, all local data is also on the ZFS and is also compressed to save space. Another tool I have in my Kubernetes cluster is quite popular, it's Cert Manager. If you ever work with Kubernetes, you know what that is. But if you don't, it's a simple application that can talk with Let's Encrypt to generate certificates for your ingresses. It can work with HTTP01 validation mode as well as DNS01 mode when you configure it to do so. I have it running with DNS01 mode because some of my domains are on the Hetzner DNS and others are on Cloudflare. So it's not most straightforward configuration ever, but it works pretty great and I had never any issues with that configuration. Another software worth noting is Garage. It's S3 compatible object storage solution. It's highly available by design and takes a very low amount of resources both in terms of CPU and memory usage. So it's great for my use case. I use it as a backend storage for GitLab, Prometheus and other stuff. And speaking of GitLab, I am not hosting GitLab on the VM using Omnibus installation, but I am using Kubernetes to host GitLab. It's almost highly available. I still have to work out PostgreSQL and Redis to be fully highly available, but all the GitLab components are running as 2 or 3 replicas of their pods, and even Gitali is running in 3 replicas, so my repositories are always available even when one node is shut down. This is good compromise because PostgreSQL and Redis don't change that often as actual components, so I can live with very short downtime when doing upgrades or when those databases had to start on another node. But other than that, GitLab upgrades are seamless and zero downtime. I also have Grafana running here. Grafana consists of multiple components. I have my Grafana namespace, which contains just Grafana application with dashboards. I have Grafana Mimir, which in simple terms is enhanced Prometheus that is highly available. It serves as Prometheus data source to store metrics from my nodes. It can run as a standalone binary as well as microservices. And as you can imagine, I am running it in microservices mode, so it's highly available in my cluster. I also have Grafana Loki running. Grafana Loki is very similar to Mimir, it's just for logs, not for metrics. It's based on Mimir, so its architecture is very similar. I have also infra namespace. This is kinda history. The idea of that namespace was to install all infrastructure applications into it, so I don't have thousands of namespaces later, like Nginx Ingress, Cert Manager, maybe CSI, but idea went away and only Nginx is running inside still and nothing more. So maybe someday I'll fix that. Another thing I have very interesting is Spiegel. It's interesting piece of software because it allows to share container image layers in peer-to-peer manner between different nodes. So with this, you can run your deployments faster because other nodes don't need to download image from the internet, but instead they can download that image from other node in your Kubernetes cluster. And also, it can reduce risk of getting rate limited on Docker Hub or similar registry hostings due to many downloads happen from your IP. I highly suggest check out this simple software, but unfortunately it doesn't work in every environment as it needs specific containerd settings, which is not possible to set in some cloud providers. Moving on to very recent stuff. I have a libvirt, which contains libvirt application that allows me to run VMs directly in Kubernetes by using CRDs. So far I'm testing this, but I hope running my next training session on VMs managed through libvirt. I have CDI namespace, which is a tool called Containerized Data Importer. It's a helper application for libvirt that allows for easy and automated image importing, as libvirt images can work in many different ways, being stored as container images or in PVCs, which in this case you need to copy data over to those volumes. So CDI will do that automatically for you. If you don't have CDI, you have to install operating system inside your PVC on your own in order to be able to boot VM. So that's quite convenient. I don't really use default namespace except very basic tests of singular stuff, but really I don't use it. There are also some personal projects I want to keep private, along with some clients namespaces, because I host Grafana dashboard that uses my Mimir and Loki for a client, so that's why some stuff is blurred here. Below my Minisforum computers, you can find one use case containing quite old computer I've got for a totally different project years ago. Right now it serves as a main router for my Homelab. It's old mini ETX motherboard, Gigabyte GA H87TN, equipped with i5 4590S and 12 GB of DDR3 taken from old laptop. So yeah, it's 10-year-old hardware, but it still works. I just added 10G TP-Link NIC to it and connected to that bigger 24-port switch. It works great so far, it doesn't need a ton of horsepower. And as you already know, I like experiments, so I didn't use any pre-made software like OpenSense or OpenWRT. Instead of that, I just installed Debian and configured iptables, PPPoE connection to my ISP, DHCP server via DNS mask queue, and some other small utilities. The router also serves as entry point to the whole network, including HTTP, so it runs HA proxy to forward traffic to my Kubernetes ingress, training Kubernetes cluster, and other software I may want to expose at any time based on domain. You can find also Home Assistant, which I set up just to control my lights and monitor temperature. Since I live in an apartment building, I can't really have any fancy features like remote gate opener or sprinkler, but I had issues with Mi Home and Google Home both being unable to group multiple lighting devices together, which is totally weird. So I end up installing Home Assistant on the Raspberry Pi, but I will move it later to VM on libvirt, hopefully. And at the very bottom you can find EATON UPS. To be specific, it's 5PX1500i RT2U G2 that can run this whole infrastructure for about an hour. So it's pretty great for me. I've already tested it, I've had some power outages in my building, and it works great. So that was my Homelab. Give a like and leave a comment what you would like next to see about it. Maybe you would like to know how to install GitLab in Kubernetes in a highly available manner, or maybe you would like to know how to configure other stuff. Thanks for watching and see you next time.